Hey guys, welcome to AI for Teens. My name is Dikshita Joshi, and I'll be going through the basics of AI with you guys today. All about AI made by Dikshita Joshi. What is AI? AI stands for artificial intelligence. It's the ability of machines to perform tasks that usually requires human intelligence. For example, solving math equations, writing an essay, or even solving your own problems. AI is used in many places today, such as online assistants like your AI chatbots, Alexa or Siri, self-driving cars, and recommendation systems such as Netflix or YouTube. Some of the fundamentals of AI, basically the neural networks. Our brain has neurons that sends the information throughout our brain, which leads to our actions. Similarly, AI's neurons are called neural networks. That the neural network sends the information through the model or AI, and it leads AI to make its actions. I'm going to be going through how the neural network works. First, it all starts with an input layer. It takes the raw data. Um, Data means information, so this can be images, videos, or even text. The hidden layer is basically the main function of this. It takes the data, looks at the data, and understands all the data. What I mean by this is it takes the data, the information, the images, videos, or whatever, then it zooms in, looks at the pixel, which I'll be going through in the next slides, and then it looks at what parts are important, which parts are not. It throws out the unimportant parts and keeps the ones that are important, and then with all the messy work, it kind of finally comes out with an output layer, which produces the final prediction. There are different kinds of neural networks, such as convolutional neural networks. Short form can be CNN or ConvNet, transformer neural networks, modular neural networks, and much more. Each of these neural networks do so many different things. It's actually kind of crazy to believe, don't you think? And the amount of hidden layers are numerous. You can have as many or as less hidden layers you want in your model. I'll be showing you an example of what a neural network looks like in a model. So this is the input layer. Takes the raw data, like the images, the raw images, the raw videos, or the raw text, or whatever data you're giving it. Then, like I said, there can be any amount of hidden layers. So you can have as many or as less hidden layers as you want. I'm just going to go with two because that's all the room I have on the screen. And then the input layer sends it to all of the hidden layers. Then it goes like that. And it's like a very messy drawing, trust me. It doesn't actually like look like these scribbles. It's actually so much more neater. But then the hidden layer does all the work. It combines thoughts, throws them out, thinks that some are important, and all of that stuff. And finally, it comes up with a output layer, which is the final prediction. It kind of looks like that, except this is like a much messier drawing. Trust me, it's not usually like this, but you will see future examples. Now let's look at computer vision. Computer vision can create videos and images. When creating a video, we have to give the model a bunch of images, and computer vision kind of works like a flip book, like the videos, because you draw stuff on a piece of paper and then you flip it, which makes it look like it's actually happening. Similarly, with computer vision, you feed it images, and with the images, we combine all the images, which creates a video. Um, Computer vision can see what the image is. Here's an example. So this is the example I'm going for. It's kind of confusing what I said, so let me just explain to you. So these little tiny squares are called pixels. So neural networks is all reliable on numbers, literally nothing else. only numbers, not color, not brightness, not activation, not anything like that, just numbers. So each of these pixels are based off of each number. So since pixels are blurred out and it's kind of hard for the model to see how what the image is, it looks at it based off of numbers. So if it sees 0.0, then they know that's not important. So the hidden layer throws that out. Then, if it even sees 0.1, they know that's really important. And they start to put all these pieces together and finally realize, oh, it's the number 3. Isn't that cool? That's like actually crazy. Um, so like I said, they're all just reliable on numbers. The numbers on an image represent the brightness and the activation and tell the model on what to do focus on using all numbers. That's what I just told you about. A pixel is the smallest dot, and many of the smallest dots make an image. So even each pixel matters, even the ones that aren't there, the ones that especially are there, that's what creates an image. There cannot be an image without pixels. So let's talk about the sizes of a pixel. The size of a pixel is a 28 by 28 pixel. That's because there's 28 pixels right here. Oh, okay. There's 28 pixels right here, and there's 28 pixels right here. That makes it a 28 by 28 pixel. Is that cool? And then that means 28 pixels are vertical and 28 pixels are horizontal. And pixel contains a numerical value that represents the brightness and the color. Like I mentioned around here, that they're all reliable on numbers. Okay, now let's talk about neural networks in computer vision. Each pixel is an input to each neuron in the neural networks. That's crazy. Basically, like I told you on the very first slide, this is how the neural network looks like. So the input layer should be like around there, like feeding in all the data. And then it gives so many hidden layers. The colors represent all the important parts, and the black parts are not important. Then it finally does all of its work. You see all of these lines just doing all of this work. It's really complicated. It like looks very complicated, but it's very easy to understand. And then it finally releases with a final output, which in this case would be 3. That's really cool. When I'm looking at the sizes of the pixel, that means that the actual input layers, the amount of hidden layers, first would be, or the size of the neural network would be both of those sides multiplied. So in this case, we have 28 pixel and another 28 pixel, right? So then you would multiply those two, which should give you 784, which is the size of your actual neural network. So I find that very cool that math can also help with this. So like I just said, this is a 28 by 28 pixel, which is equal to 784. So our hidden layer will have 784 pixels while being trained. Also, a tiny fun fact that is not that secret, but just cool to know, is did you know that the output is calculated based off the sigmoid function? So the hidden layer doesn't do all the work. There's this tiny other layer that some people tend to ignore. It's called the sigmoid function, which calculates the output layer again, because it's all based off of logic. Okay, training neural networks. The amount of times the neural network gets trained is run on epochs. Epochs is the unit of training the neural network. So epochs is, like I said, the unit of training the neural network. So if you train it on 50 epochs, that's good. If you train it on 100 epochs, that's even better. If you train it on thousands, that's even better. So the more epochs you train it on, the more accurate your model will be. A learning rate is a number that controls how fast a machine learning model learns. So it's just the speed and accuracy how it can learn, because obviously it needs to be accurate. I can't just take all the data and just produce a wrong answer, but trains very fast. That's not how it works. It also needs to be somewhat accurate. Next is training the data set. So we give a bunch of images for whatever. For example, I'm gonna take dog breeds, okay? So if you feed it some images of dog breeds like Golden Retriever, Maltese, or Labrador, or some of those dog breeds, but you don't give them all of the dog breeds, then uh for the AI to look at, then we train the model. So by feeding them those images, they can know how the dog breed looks like puppy or dog form, or we give it as much of the breeds that we know. That's just an example. Then we have text testing the data set. This is where we give it images other than the ones that we use for the training, and then we test it to see if we can detect what the image is. So for example, if I have a Pomeranian dog, I gave it a white, fluffy Pomeranian dog, but now I give it like a gold, brown, non-furry Pomeranian. It's still supposed to detect the if it's a Pomeranian or not. And that's crazy, don't you think? Um, then a split of data means dividing your data into different parts to train and test a machine learning model. So what it means by this is if you're talking to a child that doesn't know words, or you're teaching them words, then you have to break it down into syllables. So similarly, this split of data divides them to make it easier for them. And finally, where all of this happens is on the GPGPU. This is where the model is trained on. The modalities in AI. The modalities in AI are best basically senses in AI form, so like sight, vision, stuff like that. Natural language processing, short form can be NLP, is basically written text or text documents like writing, reading, and etc. Computer vision is basically vision, sight. In AI, some examples are images and videos. We had a big conversation about that. Audio, wave files, which is basically can detect the frequency of the talking and gets trained like that. Time series, continuous numerical values, for examples, EKG and environmental sensors. So basically sensors or like stuff like that. So some applications AI can be used in, I just listed few examples. There are a bunch more, so I want you guys to also look out for some applications and maybe test them. Medical devices, detecting diseases, prescribing medicines, and maybe even finding cures. If we can find cures, that's a great way to help. Agriculture. We're literally eating all of the food, so AI helps with making the food quality better. We don't like the food quality because people can use nasty fertilizers, the chemical ones, and bugs go on and eat all our food, and AI can just make that so much easier to make our food quality so much better. Marketing. AI can help sponsor business. And just an example is Netflix can recommend shows for you to watch based on your previous history. Like when you watch a show on Netflix, it looks at that and sees, oh, maybe this person would like this show based off of their previous watch history. So Yeah. And these are just a few examples of applications. There are a bunch more. So I want you guys to look out for that. For me, the most interesting application is medical devices because I think this is the most interesting because it can make a big impact on the world. Not saying that any other applications can't, but it's like detecting diseases. This can save lives. I feel like everything else is just marketing or like food. I just feel like this is like a really big impact. Like, and then detecting diseases because lots of people find out if they have a disease at the last stage, and then people don't have hope anymore because they find out at the last stage. So maybe there can be some detecting diseases or some tests that maybe people can take. And then there could also be finding cures. Because finding cures, there is no cure for like literally any diseases like diabetes, cancer, you name it. Maybe there are some, but it's a 50-50 chance. But cures can be 100% chance. So that's just great. You know, you save so many more lives. And that's the end of this slideshow. Thank you so much for watching. Make sure to like and subscribe, and I'll see you guys next week. Bye.